Hello, ladies and gentlemen, and welcome back. Welcome back. We're still looking at our grade 8 Gauss from the year 2010, but we are on the second last question, question number 24. So hopefully you've given it a try. If not, I would encourage you to pause the video and try it out for yourself. Two circles have a radius of 10 centimeters. They overlap so that each contains exactly 25% of the other's circumference. Okay, just as shown. So here we've got this overlap here. This kind of reminds me of, I think it was question 16 or 17? Yeah, these two, where the squares were overlapping. Except here we're being sort of told a fraction of the area that's overlapping. Anyways, we want the area of the shaded region, but we've got an is closest to. So the area of the shaded region is closest to, probably because there's a pi somewhere in there. But with a question that says is closest to or rounded to the nearest tenth, there's all sorts of questions like those that can pop up. That's the sort of thing where you really, really want your calculator. In certain circumstances, knowing things like the square root of 2 is about 1.414, that can get you there, or that pi is 3.14, about 3.14. That can sometimes work, but you really want your calculator so you're not doing a whole bunch of calculations by hand. So I've got my calculator ready. I'll use it if I have to. But these are really the only questions that I feel it's necessary to have a calculator for. Okay, so area of the shaded region is closest to. We've got exactly 25% of each other's circumference, which means this arc here is 25%. Okay. How are we going to be able to get this? Well, draw a picture, certainly, so that we can start messing about with it. It's not quite a circle. It'd probably be fine for my purposes, but I do at least try to pretend I can draw pictures. It's still not great, but alright. So this blue amount here is 25% of this circle, and purple 25% of our other circle. Now, the circles are the same size. They really are. Now, what can we do? Well, it's really hard to get intersections of circles. I think the technical term for something like this is a lune. L-U-N-E. I might be mistaken. It's not a term that comes up a whole lot anymore. But I think that's what we're looking for. And it's really hard to calculate something like this because it's not a very common shape. But if we come along and split it in half, and then we figure out this portion here, if we just double it, because the circles are the same size, there's a whole lot of symmetry going on, I just need to figure out this shaded area and multiply it by 2. Okay. So this changes the question a little bit. I can actually just consider one circle, assuming I could draw a circle. Let's see if we can do a little better. What I need to do is have like a cup here or something that I can just sort of trace whenever I feel like it. Okay. Well, let's put it over here. That way the picture is not sort of crammed at the bottom there. So what we're really focusing on in a single circle is that a quarter of its circumference is bound on this side, and we want this shaded area here. Now, if a quarter of the circumference is over here, well, we can actually figure out an angle here, and we know the radius here is 10 centimeters, and that can help in our calculations. And if I want this shaded area, well, it's going to be the whole circular sector minus this triangle here. Okay. So the question is, well, what's this angle? Because that's really going to determine the triangle. Now, it's not going to be a particularly bad angle. In fact, it's going to be 90 degrees because we've got a quarter of the circumference. So we got 1/4 here, then we could get another quarter here, and another quarter here, and another quarter here, and it just takes 4 of these sections to go around the circle. So you can see this is going to be a right angle. I'll show another way to get that in a moment. But in a more advanced contest, something past grade 10, you could expect all sorts of angles here, because you know trigonometry at that point. You can use the trigonometry to get the area of this triangle here. But we don't have anything quite so advanced. This is only a grade 8 contest. Okay, so let me show you another way to realize that the angle there is 90 degrees. If I have a circle, and I have just a section of it, and I know the circumference is, it's going to be 1/4 of the total circumference C. Well, what's the arc length of this section if I know the angle is theta? Okay, if it was a full 360 degrees, we'd have the full circumference, and that would be 2 pi times the radius, right? Okay, but if it's not a full 360, you're going to have some fraction. You're going to have theta out of 360 degrees. Okay? But this is going to be, well, 2 pi r is the full circumference C. So you get a fraction of the full circumference, but I already know I've got 1/4 of the circumference. Divide through the circumferences, multiply by 360, and you'll get theta is indeed 90 degrees. So that's a more formulaic approach to realizing it's 90 degrees. I'm fine with the intuitive, well, you just gotta do 1, 2, 3, 4 quarters to go all the way around the circumference. And so the angle should be 1/4 of 360. That's perfectly fine to reason your way through it. This isn't a written contest. No one's going to be marking you on your reasoning as long as it's correct. Okay? So either way, we get a 90 degrees. And so what do we need? We need the full circular sector with 90 degrees, which admittedly this doesn't quite look like 90 degrees. But we need this area, and we need to subtract off the triangle. Okay? Now we know the radius is 10 centimeters. So now I've got a right angle triangle with a base of 10 centimeters and a height of 10 centimeters. If you're having trouble seeing that, rotate it slightly, and you really do have your base and your height. So this is going to be 1/2 base times height. And then, okay, how do I find the area of a circular section if I know its angle? The exact same way we did the circumference. You take the full area of the circle, and then whatever fraction you have, which in this case is going to be 90 over 360. We just talked about this. It's got to be 1/4. So this area here is pi r squared, and we take 1/4 of that. Okay. So in total, the shaded area that we have to double is, well, 10 squared and 10 times 10. These are both 100, so it's 100 pi by 4 minus 1/2. And now I need to double that. Double that, and I get the full area that we're being asked about. So how do I double that? We'll just do 200 pi by 4 minus 1/2. Okay? And so, well, now I just need to work this out. Okay? I'm just going to, for fun, see if I can do it without actually grabbing my calculator, but I'll grab my calculator in just a moment to confirm it anyway. So 200 and 1/2, that's going to be minus 100. 200 over 4 is going to be 50, so we're looking at 50 pi minus 100. So pi is about 3.14. So if I multiply that by 50, I'll put the 0 at the bottom. 5 times 4 is, actually, let's do this. Put the 0 here. 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. Then 5 times 3 is 15. And I got to make sure the decimal place goes exactly where I need it. So 157.00. So subtract off 100. And I should be getting something very close to 57. It's not going to be exact, but 57, is there anything that's close to 57? Yeah, there's only one that's kind of close to 57. That's 57.08. So I'm going to say the answer is A, and I did it without a calculator. But, okay, I'll grab my calculator just to confirm. So, here, you can watch me do it. I don't know. I never know whether or not to just leave it on the screen or leave it on me while I'm doing this. Pi by 4, about 0.78, minus 1/2. So about 0.285. And now I want to multiply it by 200. 57.079. That would round up to 57.08. Okay. So this was one of those situations where I guess I could get by with the approximation, but the calculator would have been so much faster. Okay. So there we go. That finishes things off. 57.08 and an answer of A. So up next, I think we're almost done the contest. We just have question 25 to go. I will see you for that in the next video.